Okay.
Okay, good morning, everyone. Welcome to this third and final episode of our trilogy. And I was just thinking how far we've come since the first one a couple of weeks ago, where we were talking about how to envisage a well-adapted university, how to engage with key stakeholders, how to figure out who or what is most at risk from climate change, and then the types of measures that we might implement. Well, this week we're going to be moving towards the final steps where we try to think how we might rationally select a smaller set of adaptation options to achieve intended benefits. And this is actually trickier than it might sound, because when we're talking about adaptation, we're often thinking about actions and benefits that might not be realized for some time into the future. So how can we measure something that's in the future? And that lies at the very heart of what we're going to try and unpack this morning. So just to recap what we covered last week, we saw that risk is the product of likelihood of consequence, where likelihood is the chance of something bad happening, and the consequence is the scale of the impact of that bad thing happening. And we saw that we can define risk using a range of metrics. They might be pound signs, they might be hours of disruption. The important thing is this can be customized to the local circumstance. We also showed how risk matrices, which are familiar to many of us, can also be applied in the context of climate risk assessment, and they provide a convenient means of mapping priority risks. The important thing here is to be very clear about the nature of the receptor. Are we talking about an individual building? Are we talking about a campus? Are we talking about a process? Are we talking about a group of people? And this is an issue that I'll return to later on this morning. I also gave pointers to a number of adaptation typologies and checklists, where rather than having to think from scratch how we might adapt to heat or flood risk or biodiversity challenges, we can turn to these existing checklists, at least for a first idea or some suggestions as to the types of activity that we might undertake. And I also explain the importance of trying to foresee and sidestep any possibility of locking in or reducing the possibilities of other options in the future, or worse still, amplifying the risk by making a poor decision now. And finally, I was encouraging us to think about implementing low regret actions first. These are the types of activity that will deliver benefits against climate variability and change now and in the future. And a good example of that would be a good heat wave forecasting system is going to be super useful to us now, and it's going to be useful to us in the future. Here's the risk matrix, which I used to illustrate the point last week, and you can see across the top here scales of consequence in pounds, going from the lowest impact of the order of a few £1,000s to potentially millions of pounds of damage or disruption. And here I've suggested a scale that goes from very rare events, 1 in 20 years, to an event that might occur every single year. Now, I think someone asked, well, how would some of the big issues identified by the National Risk Register map onto this same matrix? So I promised to go away and look this up. And what's interesting here is that the likelihood scale is different to the one I've just shown you. So you can see a number 1 at the bottom is actually a 1 in 500 year event. You might be thinking, well, what on earth should we be doing about a 1 in 500 year event? Well, actually, a 1 in 500 year event is mainstreamed into water resource plans now. So, for example, water companies have to consider the resilience of their whole supply system to a 1 in 500 year drought. So, as extreme as it might sound, there are already some sectors and practices out there that are thinking of events of that rareness. And then we can see it's a non-linear scale as we go up from 1 to 2, 3 to 4, and 5. On the second table, you can also see that the scale of the impacts when we look at climate risk at a national level are orders of magnitude greater than they are at a campus level. And this is to be expected. So my maximum disaster cost here is of the order of millions of pounds. And I know that some HEIs have already experienced some damages in tens of millions, but I suspect that's a fairly rare and extreme case. Here you can see when you think about it at national level, we're looking at billions of pounds of damage for the most extreme events. And this underlines the point I was making earlier, that being clear about the nature of the receptor, the domain that we're working with, whether it's an individual building, a campus, or a whole nation state, defines what would be a sensible scale for those likelihoods and consequence scores. And you may be thinking in terms of your own institutions, in terms of looking at risk for individual buildings or departments or operations or supply chains, so may want to invoke different metrics in those cases. So when we look at some of the climate impacts at a national level, and we compare them with, for example, a pandemic, which in the past would have been regarded as a highly unlikely event, or much lower likelihood than it is now that it's actually been experienced. But you can see the catastrophic impact of the pandemic in the top right there, in orders of billions of pounds of damage. But then at a national level, floods, droughts, and storms generating significant impacts. And you can see the likelihoods here in terms of the 1 in 100 year for a 2 scale likelihood, or a 1 in 20 year event for a 3. So just to underline the point, it then, it does become actually pretty hard to map those national scale consequences and likelihoods onto our little campus level matrix. And I've just shown this, that in order to capture storm and loss of drinking water, I actually have to extend out to the category 6 and 7, and I have to invent a new category for very rare to capture loss of drinking water. So hopefully that underlines the importance of being really clear about the scale, the boundary, the type of receptor that we're looking at. I also strongly advocated the use of the Biogini typology. You can click on this link and it takes you to a really nice list, an inventory of adaptation options, which were then used from a bottom-up process to identify these major categories of adaptation activity, involving developing human and technical capacities through to changing behaviors, strengthening monitoring and forecasting systems, and then conventional things, building new infrastructure, flood defenses, or using green solutions to moderate heat and so forth, or financial instruments. And I think last week I suggested that typologies like these provide us with a really useful rubric for checking that we've not just homed in on an infrastructure solution or a behavior solution, that we are thinking more broadly and in a more holistic way when we approach adaptation. There are also other nice resources online. Climate Adapt provides an inventory of nearly 60 adaptation options. And as you can see from the two examples here, not all of them are going to necessarily be applicable to HEIs, though nonetheless, maybe there will be an increased risk of vector-borne diseases on some campuses, depending on the spread of insects and other things, the amount of water bodies, etc. But there are probably few of us that are worried about impacts on precision agriculture on and around our estates. But if you dig into this list, there are lots of other ideas and suggestions which provide food for thought. That's the main thing. Okay, so last week I set a number of tasks to go and read the third part of the Times Higher Education Campus series, and then to think about how your particular climate hazards might map onto the risk matrix. So now I'd be interested to hear what, if any, receptors you would choose to focus on. Would you try to approach this at a campus level, at a building level, at a departmental level? I'm open to your thoughts and suggestions. What do you think you would do if you were to implement this matrix? Feel free to put your hand up or enter something in the chat.
I always think about approaching it at building level.
Yeah.
We don't really, I mean, you all know where Liverpool is. I know we're a sort of coastal city, but I think it's overheating really, which appears to be our main issue. And then really, because all our buildings are so different, we would look at them at an individual building level really, because I think some might be more susceptible to that as an extreme than others. I mean, I certainly, you know, when it was very, very hot, was it last year when it was reaching 38, 39 degrees, you know, our cooling systems couldn't cope with that at all. It was too hot. And I found that I really found that fascinating. In my head, I thought, oh, cooling system will work under all conditions, but I couldn't believe that that the M&E plant, you know, it was just too much. And I was like, I actually haven't explored that myself yet as to where we go with that. Do we just need stronger refrigerants? But if we do use stronger refrigerants, that goes against our climate change mitigation strategy. So it's an area I haven't explored yet, and I want to when we do this. Okay,
great. Thank you very much, Nia. So in your case, if you've got a list of say 20 or 30 buildings, you might be applying a risk score to each of those buildings to identify, perhaps on the basis of their age, the fabric, the amount of shade, the existing cooling systems, a whole raft of criteria that you might use to devise some risk score that helps you to identify the buildings that are highest priority for action. So that's really interesting, and I know that that's the approach that's been taken by other HEIs to go at this on a building by building level, again because of potential concerns around overheating, and in other cases building exposure to surface water or fluvial flooding or even sea level rise. Okay.
And yeah, sorry, just one more point as well. We are sort of diversifying what we're teaching as well. So rather than just having that sort of standard year, we're taking on a lot of nurses, and they study throughout the year. So during those hot summer months, so they're more vulnerable to having that. So again, that dictates, you know, that will shape our medium-term strategy, you know, depending on who we're teaching and when we're teaching them.
Yeah, that's excellent. So you in a sense got blended two types of receptors. So which are the buildings of most concern and which are the groups that are most exposed to the heat? And then that really helps you to focus your attention on managing those risks as a priority. That's great. Thank you, Nia. Any other thoughts? Okay, so if I just move on then, at a campus level, I've shown here this image before, we were able to map where we might see the risk of droughts, heat waves, floods, and so forth for the present, and then using a simple arrow like this as a way of communicating to senior management the direction of travel that we expect these risks to move in. So how, for example, we might expect to see increased likelihood of flooding and heat waves, but less likelihood of snowfall. So it provides a very powerful means of communicating these risks. So if we sort of just concentrate, just as an example, the situation of flood risk at Loughborough, which I've mentioned before. This is a map taken from the Environment Agency's flood mapping system, where you can see that the southern and eastern part of the campus is vulnerable to surface water flooding by these a stream on the south and then another stream on the north, which can cause localized flooding and disruption. We can also turn to the Environment Agency's lookup tables, which say how much extra flood risk we need to factor in for climate change in different zones, whether we're in flood zone 3A or 3B. And these zonations also dictate the type of activity that can go on there and also the amount of climate change allowances. So I think this was a point that was raised last week. Are there any formal processes already in place that are relevant to HEIs? This is an example where the Environment Agency has laid out the climate change allowances, the factors, the uplifts, the safety margins, whatever words you want to use, that are needed to accommodate climate change in future flood risk when submitting applications for new developments. We can also turn to the output from the UKCP18 projections, which tell us the probabilities of higher rainfall in winter and in summer. And what this information shows us is there's a lot of uncertainty in these projections, and the lookup tables, which you can see here on the right, table 1 is again taken from the Environment Agency's information. There are a number of values that reflect the amount of uncertainty that's being addressed. So if we're super precautionary because we've got a highly vulnerable activity, or we have to be super careful about a particular piece of infrastructure, then we'd be looking at an upper end allowance, even by the mid-century, of 40% factor for flood risk. So these are not insignificant changes. And then on the bottom right hand side, latest evidence suggests that for every degree of warming we're going to see at least 7 to 8% increase in the intensity of very heavy rainfall. So these are consistent messages that are coming out about the need to prepare for heightened flood risk in the future. So what might we do on campus and around campus? We've heard already about the value of good maintenance regimes, ensuring that drainage systems are kept clear, avoiding future development in areas of the campus which are known to be prone to flooding, using super high resolution flood warnings to warn people to evacuate or to move equipment, out of harm's way or to install temporary barriers. Strategically, over longer terms, we might be factoring in allowances, like I've just shown you, for climate change in new infrastructure, even building bunds or embankments to protect critical infrastructure, or retrofitting buildings that are already being impacted by flooding, by replacing floors and wiring and so forth, protecting green space to reduce the amount of runoff, and over time moving to more permeable pavements and surfaces. So you can see a raft of infrastructure type options, maintenance options, behavioral options within this portfolio. So now moving on to the main deal for today, how do we then go about prioritizing those options and monitoring the expected benefits and outcomes? And I've already pointed to this analogy of thinking of adaptation lists as a toolkit, and going to the toolkit and trying to select the most appropriate tools for the risks or the job at hand. So here we go. If I turn the question around and I say, here's a list of potential adaptation measures, what criteria might we use to say we'll prioritize one or more over others? So I'll just pose that question, see what you think. What should be the criteria for prioritizing one option over another? Any thoughts? Claire, because I can see you're thinking hard about this. Can I put you on the spot and ask you what sort of criteria might you use to say, look down this list, which ones should we go for first, or should we prioritize?
I think I would look back to the risk matrix that we talked about just now and say, which ones are the greatest risk in terms of financial risk or likelihood as well, and then which would address those issues. That's what I was just thinking about there.
Okay, so we might, turning that around, we might say which one of these measures would be the most effective in reducing the damages, let's say, at the priority buildings or the impacts on the priority groups. So effectiveness would be a good one, wouldn't it? Because that would connect us back to the matrix. Anything else? Anything in the chat?
Yeah, Joanne from West Yorkshire Consortium. Likelihood and consequence of the hazard occurring.
Okay. All right. Thank you very much. So here just to stimulate a little bit more thought and discussion around how we go about prioritizing options when we've got a lot of possibilities. That's what I'm saying, is that we might have 10 possibilities, but we can't fund them all. We haven't got the resources or the people available to deliver all of these. We haven't got the technologies or the monitoring systems in place. So how do we prioritize these? Here's a suggested list of 8 criteria. So effectiveness, I think that was what Claire was touching on, and the other contribution on the chat. Functionality. So how safe is this intervention? Will it interfere with existing operations? Can the adaptation be upgraded in time if the risk continues to grow or change? Does the intervention deliver more than one benefit, perhaps reducing flood risk whilst also enhancing biodiversity? How long will the intervention deliver benefits for? How easily can it be implemented? And what might be some of the wider social or environmental negatives of construction or implementation of these measures. So this might seem like a really extensive list of criteria, and it's one where we might be inclined to apply if we're having to make quite a big investment decision or trying to weigh up a long list of options. So we could score all of those options I've just shown you on a scale of 1 to 10 to say which of these are most effective, most adaptable, have greatest longevity. So we could create a little matrix showing the scores against the different criteria. I'm just going to skip across this one, and this is exactly what has been done in this really lovely example. So you might be thinking, Rob, why are you talking to us about Tuvalu? That's a long way away from where I am. What on earth can I learn from Tuvalu? Well, actually, if you click on the link, this is a really lovely climate risk and vulnerability assessment, which takes you through the whole journey that we've been covering over the last few weeks. But best about this, in my view, is it shows really transparently how to weight these different criteria and then use this as a rational way for deciding which of the options to prioritize. And it's a relatively straightforward case here, because in Tuvalu, the primary risk is from sea level rise and storminess. So they've got a clear understanding of the direction of travel and the nature of the risk evolving. But nonetheless, I think that has parallels with some of the concerns that we've explored already. If temperature is a risk that's rising and going in one direction, then it has some analogies. And you can see that the islanders rated functionality and adaptability and effectiveness as the most highly sought after criteria, and attach less importance to environmental and social impacts and ease of implementation. And it's possible to then, as I say, attach a score to and a weight to each of those criteria. And if you've got several options here, you can tot up these scores and divide the cost by the benefit to give you an overall score. So this is a more elaborate and sophisticated level of analysis when you really have to perhaps make a strong financial case for one investment over another, and it's worth doing this. It doesn't actually take that much time to do, provided you've got good cost estimates of each of your adaptation interventions. So that's easier said than done. Nia's probably thinking, well, how much would it actually cost me to retrofit this building or that one? Would it be even straightforward to obtain that sort of information in terms of the costs of adaptation? So it's not straightforward, but it allows us to evaluate the cost effectiveness of different interventions. Any questions on this? I can see a number of points in the chat. Claire, anything that we need to cover at this point?
Yeah, so it was just back to about the criteria and the prioritizing, and there was a couple of comments. So Diane from Liverpool John Moore, prevention measures, and then Steph from Kingston, opportunities to implement, i.e. if a new building was going to be built, you would want to avoid a floodless area.
Yeah, that's great. Yeah, so sort of future-proofing those investments, sort of foreseeing the environments, the climate environment within which it's operating. And of course, these criteria and these weights are going to be highly context specific. So the weights that I might attach and apply for Loughborough for flood risk might look very differently to the weights that would be attached at Liverpool John Moores for temperature, depending upon local circumstances. So it's customizable, which is a key point. But also, even if we don't go down the route of quantifying or attaching numbers to these things, at least we can be transparent about the qualitative things that matter most. Are we most concerned about something that is not going to interfere with operations and is going to work well for a long period of time? So we can even use these indicators, these criteria, in a qualitative way to support the decision making. Just before we move on to the final step, I just would like to raise a cautionary remark. I'm guessing that many of us through our work come across reference to measures around nature-based solutions. So these are certainly rising in prominence in all sorts of sectors, and are an extremely appealing idea that we can work with nature and deliver benefits by working with nature-based solutions. There's a bit of a tension here, though, in my mind. I mean, can we really solve flooding? No, we can't. So even the language around some of these technologies is a little bit problematic. So I think it's important also that we don't overstate the potential of some technologies, that we do not raise expectations that can't be delivered, because it is at face value a very appealing idea that we can work with nature and solve flooding. But here, just as a rather whimsical example, I came across this sign earlier in the year where beavers had been reintroduced to produce let me start again. Beavers and the possibility of beavers for reducing flood risk downstream is something that we've seen a lot, quite a lot in the media. But here you can see a particular heavy storm washed away the beaver lodge, the structure. They began to repair it, but the point is that there's a limit to how much these types of intervention can help us. Now, I'm guessing that very few of us would be reintroducing beavers or be relying on beavers for local flood protection, but many of us might be relying on small ponds, sustainable urban drainage systems, and green spaces. And this is a synthesis paper where we looked at the performance of all of these nature-based methods as a means of controlling flood risk, and used all the available scientific evidence to really shake down and say, how effective are these measures, as a cautionary remark. And I think what we took away from this is, yeah, these small ponds, green spaces and SUDs will deliver some benefit for small flood events, but they pretty much become overwhelmed at more extreme events. So we can't totally rely upon nature-based methods to deliver protection against some of the intermediate and very large flood events that we anticipate. So I just put that as a cautionary remark about how we communicate the use and the efficacy of some of these green methods. And I'm happy to take any pushback or comment on that at this stage, or whether indeed those of you on the webinar share these views. Okay, so perhaps a good point to then pause and reflect again. So based on what you've heard, what criteria might you think as being the most important for your HEI? We've already heard about some of the adaptation actions around heat management as a priority. Are there any sort of strategic actions that you might be thinking of taking? So if building indoor temperatures is a concern, what are the strategic possibilities? Let's open the floor to comments. Any thoughts on that? Okay, well, we'll just leave that there for future reference. It may be something, a little checklist that you might like to come back to as you consult with your stakeholders and senior managers in terms of what do they care most about? Is it cost effectiveness? Is it environmental sustainability? Is it maximizing carbon sequestration as a co-benefit, and so forth? Strategically, we might be thinking about how to incorporate some of these adaptations within estates and buildings and energy plans. So remember, we went back to some of the key documents at our HEIs, which could provide entry points for some of these adaptations. Okay, final step then. How do we monitor progress? What does successful adaptation look like? I mean, I love this photograph, because when I look at this, I think, yeah, that plant is super well adapted to this environment. How on earth can it survive in such a hostile, dry environment and thrive? So I think we know what good adaptation looks like when we actually see it. But the challenge, of course, is we're trying to foresee what good adaptation might look like in years and decades to come. And this is an issue that was confronted head on by Susie Moser in this fantastic book published about 10 years ago, where she was saying, you know, there are practical issues around measuring progress on adaptation. Like what's the benchmark, the baseline that we're going to start from? What's the indicators we're going to use? How far into the future are we going to look? How do we take into account a whole raft of uncertainties that could affect these outcomes, and the fact that future changes in flood risk or temperature in and around buildings might be driven by other things beyond climate change. So there's a whole raft of other confounding factors. And then there's a whole set of operational and practical issues around how do we report, who are we reporting the benefits to, who's responsible for collecting the data, and how do we keep watch for any potential maladaptations. So even though it's a decade-old book, it's a thought-provoking reference, and you might want to explore this as a longer read. Of course, I'm guessing most of us come across monitoring, evaluation, and reporting as a fact of daily life. We're used to doing this, and it's a case of how can we adapt existing frameworks like this to track progress on adaptation. And again, I think it's nice to turn to tangible examples, even in other sectors where people have already done this, and I think done it well. So Kuala Lumpur has produced a really amazing adaptation plan. So this is for a massive city, and I just show you here on the right hand side examples of some of the adaptation indicators that Kuala Lumpur city authorities developed. So how much green space are they creating? What's the temperature benefit of green space over paved areas? How many people have access to green spaces as a cool refuge, and so forth. So we might think of how some of these metrics could be adjusted for an HEI or a campus. So how much green space do we have? Is it going up or down? How accessible is the green space to vulnerable groups? What's the type of building that's being installed? How permeable are surfaces across the campus? So we can develop those sorts of indicator. I think indicators also, as well as a management tool, we can also look at them as a possibility for broadening engagement. And here, for example, oak bud bursts, the date of at which the color of the leaves change and the oak leaf bursts out, is actually a really nice indicator of temperature conditions, and it's linked to phenology or plant systems around our sites. And it's something that might engage citizen scientists. We could have students or staff or members of the public going out and recording the first blossom or the first budding date, the first emergence of a sighting of a particular bird or insect. Now, these are indicators of climate change, but not necessarily indicators of adaptation and the effectiveness of the measures that we're taking. So how would we go about that? Well, here's one example that came to mind, again, as a possibility for engagement. I'm guessing that many of our institutions have folk with expertise in GIS and remote sensing. So how about accessing remotely sensed temperature data over time, looking down on our sites and recording how temperatures have changed through time, or the amount of greenness? So we could be using remotely sensed information to measure some of those nice indicators used in Kuala Lumpur. If we're looking at Jeddah and land surface temperatures at a low of 40 degrees Celsius and a high of 48, that's hopefully a much more extreme case than we're going to experience ourselves. But I think, how about if we're gathering and creating maps like this at 15 to 30 meter resolution, tracking where the hotspots are on and around our sites, where are the green areas, where is the blue and open space, and how are those areas changing through time? And the reason I suggest this is a nifty way of engagement is because we could bring in colleagues with these technical skills. We could ask students to do this as an assignment or as a dissertation. So again, there's a possibility of bringing in a broader constituency in the development and the collection of these data sets that we could use to measure adaptation. And then nearly finished now, just to also point towards the climate adaptation monitoring framework developed by the UK Climate Change Committee, which again you can obtain through this link. What's nice about this online document is it provides some very practical tips on how to set up a framework to monitor adaptation, what good adaptation looks like. So again, some indicators there to think about, and how and who we should be reporting to. And I've sort of collected some of these thoughts together. Again, let's just pause here to think about these, like who should be responsible for undertaking the monitoring? Who are we reporting the progress to? What kinds of indicators of adaptation might we develop? Maybe a more complex question is, how transparent, how publicly accessible is this information? There's one school of argument that says that we could publish some of these indicators fully in the open, as both a research tool and as a communication tool to show how things are changing on and around our sites. And how often should we be undertaking the reporting? Should we be doing it quarterly, twice a year, annually? What's an appropriate level of frequency of reporting these kinds of indicator? So just pause there. And any questions or comments or remarks on what I've just suggested.
There's a couple of things in the chat. They're not actually just about for
Okay,
this.
thank you.
We're going back a bit.
That's all right.
So this is from Dan from LSE. How do you deal with the mindset on payback periods when impacts are a long way in the future? Any tips?
Yeah, so this is where you can overcome these, where if there's a strong case for co-benefits, so there might be multiple benefits realized from a particular intervention or nearer term cost savings. So trying to look at an option that addresses the climate, at least one or more climate risks, so you get multiple benefits from the investment, is one way of doing that. The way it is also done, well, there is. I haven't got into the whole issue of discounting as well. So that what's the discount rate that's being applied to the investment to convert into the net present value and so forth. So we can get into the sort of the economics of it as well. Even deciding what that discount rate should be influences how far into the future you're looking in terms of the cost benefit analysis. So that it is tricky. I do sympathize with that question. Anything else? Sorry, who raised the question? Was that from Dan?
That was Dan from LSE.
Dan, yeah. So Dan, did that help, or did you want to come back on that perhaps?
No, that was really useful. Thanks. Yeah.
Yeah.
Cheers. Yeah.
Yeah, because it is. Yeah, often it does come down to this economic cost effectiveness issue, doesn't it? The cost benefit. But as I say, yeah, if we can identify multiple benefits, that can help strengthen the case, can't it? Yeah.
Thanks.
I guess also there may be smart ways of scheduling an investment. If a building is being refurbished, that might be an ideal opportunity to look at upgrading the materials, the shading, the cooling systems during a planned retrofit, rather than adding that on to the task list. Does that make sense?
Yeah, that's something we're doing actually with our long-term maintenance. Is actually we wrap quite a lot of improvements into that as we go along, as well as the major rebuilds and refurbs. So,
yeah,
good.
That's great. So we're kind of ratcheting up the standard, the design standard and the performance standard of buildings and infrastructure whenever there's an opportunity for retrofit or upgrade. And of course, if we're building a brand new building, then it would be smart to factor in these climate change allowances for flooding and heat and wind speeds and all the other factors at the design stage.
Yeah, we've got a couple of halls of residence that are right on the edge of the Thames, but they're kind of right side of the Thames barrier. But obviously, when you think about that, and I don't know what the future plans are for the Thames barrier and how much spare capacity that's got, but yeah, that's a kind of national level thing to look at as well. But yeah, and also we're electrifying quite a few buildings in refurbs, like moving to air source heat pumps. So
yeah,
and obviously doing the fabric work around that as well. So yeah, there's quite a bit going on.
Yeah, great. Thanks, Dan. Is there anything else, Claire?
It was a comment from Dan back about making sure contractors heat model new buildings.
Yeah.
With future climate change risks, particularly upper floors, and building adaptation into design. Yeah.
In fact, a few years ago, I did a survey of who had which sectors had been using the UK climate projections most widely, and that it is actually in the building design sector. So people are using climate change projections in buildings simulations, simulating the performance of a building now and in under future climate conditions. So I think that kind of thinking is becoming much more mainstream than it was even a few years ago. Okay. Any thoughts here in terms of who we might be reporting to and how frequently we should be reporting indicators?
We generally obviously report KPIs sort of on an annual basis in relation to our mitigation strategies, and just form part of annual reporting, but I'm not sure if there would be external bodies, EAUC.
Yeah. So no, I think as we sort of discussed in previous sessions, working with an existing system rather than inventing a new one. If you've got an existing well-working process for reporting KPIs, then why not have a KPI that relates to some adaptation benefit as part of the set of KPIs that are being reported annually? So that maybe that's the conversation to have with the senior managers and the decision makers is what KPI and data do we need to gather to show that we're making progress on protecting, in your case, for example, nurses and other students particularly vulnerable to extreme heat in some of your buildings? Would it be an internal temperature metrics, an annual comfort survey? How would we do that? But I think with a bit of thought, you could devise a nice KPI to reflect progress that you're making in improving indoor temperatures. Okay. All right then. Conscious of time, just a few final remarks before we wrap up. So I hope that you found this a useful series. I hope you see and share my view that we should be really thinking of this in terms of resilient net zero. So that's a phrase that I've used a lot. Let's not see efforts to drive towards net zero as apart from efforts to enhance the resilience of our institutions. I've shown you one framework with 6 steps. I mentioned that there are other frameworks out there, and it doesn't really matter which framework we go with, but provided we just have this structure to organize our approach and the workflow that ultimately delivers these intended adaptation benefits in the most cost-effective way that we can, or whatever criteria we're implementing. I'm hoping that having joined this series that everyone's gained a little bit more technical awareness. I certainly have, from some of the extra questions I've had to go away and look up. I've learned quite a bit through this process. It may be that for some of us, we'll be doing it, undertaking this work with teams on campus, drawing in academic experts, knowledgeable folk around us, people who hold the data sets and the stakeholders. For others, it may be more about just having improved technical awareness of what this adaptation thing is all about, and being able to develop smarter terms of reference for consultants. So knowing a little bit about what a framework should look like, the type of deliverables that you would hope to obtain. It might be tell me what the key risks are, suggest some indicators of risk, and suggest some indicators of adaptation benefits as potential deliverables supplied by consultants or other partners. And then finally, I think it's important to stress that we're all on this learning process this journey, and there's so much to be gained from sharing experiences amongst ourselves. And here I once again strongly advocate, encourage those who haven't already done so to join the community of practice. There are some other resources that you might like to look at from these slides. A final reading from the campus on how to select and monitor climate adaptation, 5-minute read, or a self-directed little questionnaire on where you are in the adaptation journey. By clicking on some of these questions, it tells you what appropriate actions might be taken. So I guess my final open question is, I'm genuinely curious to hear what folks are going to do next. Has what you've seen, what we've discussed, prompted any initiatives, any new thoughts? What do you plan to do next? I'd really love to hear right now, if you've got time to just share a few thoughts for a few minutes.
I think I've said what we were going to do, Rob, which is we've got some budget this year to undertake something quite comprehensive around this.
Yeah.
And this training has helped me to see what that exercise is going to look like in a much more detailed and technical level. I go back to what I said in the first session, which I really need an external support with this in terms of a consultancy that's knowledgeable, you know, not someone who's just winging it, somebody who's got some in-depth experience around this, and can, because actually, you know, it's complex when you start bringing in, you know, the risk analysis and risk weighting, and you're explaining quite complex things that people haven't talked about before, and you do so very, you know, you're very erudite, but I need someone like that to come in and inspire the people I'm going to get into a room. So that's my challenge, but yeah, hopefully we can.
Okay. That's great. And I think you've got, you know, as you were suggesting earlier today, this idea around focusing on buildings, and an inventory of buildings, and evaluating the risks on a building by building level is an interesting way to go. And there are others I know in the community of practice who've taken that approach, who could probably share some insights on how to proceed with that. Any other thoughts?
There's a couple of things in the chat that I'll go through. Just before
Thanks,
just to mention about the community practice that Rob mentioned. If you're not already on it, drop me a line and I can add you. And we have our meeting. It's actually next Wednesday, the 4th of October at 2 o'clock. And we're going to be hearing from Charlotte, who's actually on the call, from Notts Trent, but she's going to be talking about the MOD framework that she worked on in a previous career. But yeah, you can book on via our website, or again, just drop me a line and I can sort that out for you. Just back to what sort of next steps. First of all, we've had a couple of messages from people that have had to leave, just to say it's been really informative. So that's from Natalie from London. Really useful and well presented. Many thanks, Rob. Steph from Kingston. This has been one of the best EAUC sessions I've attended. Well,
bless you.
So informative and transferable. Thank you, Rob. And then back to next steps. Sorry, Claire from Man Met. We've got a meeting set up with our house/academic specialist on climate change adaptation and resilience. That's good. And then, Steph is still here. This was really timely, as our estates director has brought up the topic of climate resilience, and we are considering incorporating the framework as part of an away day, gathering feedback from colleagues on how our buildings are impacted by flooding and heat.
Excellent. That's really fantastic to hear. And a very positive place to close this session. Thanks from me for being so engaged and thought-provoking as well. I really want to emphasize that you know, I've learned something from this as well, in terms of the extra research and inquiries and follow-ups I've had to make along the way. And just to, you know, encourage you, if you think I can offer any help, support, or advice, just drop me an email. I'm always happy to to hear what you're up to and offer any support I can. So I think, Claire, that's a good point to close. Thank you, everyone.
Excellent. Thanks, everybody. Thanks, Rob.
Okay. Bye then.